Hello friends, welcome to GT Science tutorial. In this video, we will see the law of mass action. This is the second video of the chemical equilibrium chapter. In this video, we will see what the law of mass action is and we will see the necessary formulations related to it. So let's start. First of all, let's understand what the law of mass action is. Here is the definition of it. So, the definition of law of mass action is the law of mass action tells us how the rate of chemical reaction depends on the concentration of reactants. So, this law simply tells us how the rate of the reaction depends on the concentration of reactants. Okay, so this law is the relation between the rate of chemical reaction and the concentration of reactants only. We don't talk about the product. Okay, we know what the rate of reaction is. Rate depends on the concentration, right? So it was proposed by Goldberg and Wage in 19th century. So you can simply remember how long this law is. It was developed in 19th century and we are living in 21st century, right? So, what is the definition of the law of mass action? Look at here. The definition is very simple, but as it is long, then it might be a little tricky. Let's try to understand it, okay? So, at a given temperature, that is, the temperature should be constant. The rate of chemical reaction is directly proportional to the product of the concentrations of the reactant. Okay, you understood till this much? The rate of chemical reaction is directly proportional to the product of the concentration of reactants, each raised to a power equal to its coefficient in the balanced chemical equation. This still sounds tricky, right? Let's understand this in simple way. I hope you will understand it properly. I'll try my best to make you understand it properly. Okay, so this definition simply says that if we consider a reaction A giving B, where A is the reactant, B is the product in the forward reaction. Similarly, B is the reactant and A is the product in the backward reaction. Okay, then according to the law of mass action, the rate of this reaction will be directly proportional to the concentration of the reactant. Understood? Okay, if there was a coefficient A forming another coefficient B. Okay, so if small a was the stoichiometric coefficient of capital A, then this small a would become the power. Okay, it become the power of the capital A's concentration. I hope you understood it now. Now let's see the actual mathematical derivation for the law of mass action. Okay, so this is the for the conceptual part. We will proceed now with the derivation. Okay, so let AA plus BB giving CC plus DD is a chemical reaction. Okay, let AA plus BB giving CC plus DD is a reversible chemical reaction because there is a double-headed arrow. That reaction proceeds in both the direction. Okay, now the rate of the rate of forward reaction forward reaction means this direction, right? So the rate of forward reaction RF is directly proportional, see, to the product of the concentration of the reactant. Here the reactants are A and B, so concentration of A into concentration of B raised to the power of their stoichiometric number. So small a will be the power of concentration of capital A and small b will be the power of concentration of capital B. Okay, or RF is equal to if we remove the proportionality sign, we put a constant, right? The constant is Kf. Okay, so A into B. Let's consider this to be equation number 1, where this Kf is a constant called the rate constant for forward reaction. We will write it later. Okay, also for backward reaction also for backward reaction RB will be directly proportional to the concentration of reactants, right? Reactants. Now for backward reaction in this direction, they will be the reactants C and D. So capital C, capital D to the power small c and small d. Okay, or RB will be equal to KB C into D. Let's consider this to be question number 2, where 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 this Kf and Kb are the rate constants for the forward and backward reactions. Rate constant for the forward and backward reactions. Okay, I hope you understood till this much. Now at at dynamic equilibrium, I have already explained about the concept of dynamic equilibrium in my previous video. Dynamic equilibrium is the state at which the rate of forward reaction and the rate of backward reactions are equal. That is, Rf will be equal to Rb. Okay, so if we put the values, we will write Kf into C to the power small c, a to the power small a into b to the power small b is equal to kb c to the power small c d to the power small d. Or if we do cross multiplication to find the value of kf by kb, then this whole value, a b value, will go in the right side. So it will be c into d divided by a into b. This is very simple, right? Now this is a constant rate constant for forward reaction, and this is a constant rate constant for backward reaction. The ratio of the two constants will also be constant, that is represented by Kc, and that is equal to Cc into d by a into b. This is the final mathematical form for the rate constant, no, equilibrium constant, where this Kc is the equilibrium constant in terms of molar concentration. Okay, so I hope you understood properly till this much. This is the derivation that is frequently used in law of mass action. Okay, now let's move forward. Okay, so let's do a real example. How do we write Kc for a real example? Let me write a chemical reaction H2 plus I2 giving 2Hi. Okay, this is in gaseous state, this is also in gaseous state, this is also in gaseous state. So what kind of reaction is this? Homogeneous equilibrium reaction. So for this reaction, the value of Kc will be equal to, look at here, the concentration of product divided by the concentration of the reactants. Okay, concentration of the reactants. If you notice closely over here, Kc will be equal to the concentration of products in the numerators and the concentration of reactants in the denominator. We'll do the same thing over here. What is the product? Hi. So we will write Hi over here. What is the stoichiometric coefficient of it? 2. So we'll write 2 as the power. So over here, what is the reactants? AS2 and I2. These are the reactants, right? And their stoichiometric coefficient is 1 and 1, so we don't have to include that over here. So this is a real example how we write Kc. Kc means equilibrium constant in terms of molar concentration. Now, what are the important points about Kc? What are the importance of Kc? Look at here. So Kc is a constant at a given temperature. So that is a constant at given temperature. If temperature varies, the Kc will also vary. Similarly, Kc only includes gases and aqueous substances. So Kc is only used for gases and aqueous substances and not for solid substances. Okay, and solids and pure liquids are not included in the expression. So solids and pure liquid, yeah, liquid can be ionic form, but pure liquid cannot be included. Okay, cannot be included. So example of a reaction with solid. We know an example. We know an example of a reaction with solid. Okay, calcium carbonate giving giving calcium oxide plus what? Carbon dioxide. This is solid. Calcium oxide is solid and carbon dioxide is gas. So in this term, in this reaction, if we want to write the expression for Kc, then Kc will be written like this. Okay. So look at here. This is in gaseous state and these are in solid state. So we don't include the solid states. Okay. We only include the gaseous state. So over here, carbon dioxide is the product. So we will write carbon dioxide in the numerator. But in the denominator, is there anything? Is there anything that we can write that is in liquid or gas? No. In the product other than carbon dioxide that is in liquid or gas? No. So this will be the complete expression for the Kc. I hope you understood about Kc. Now let's move forward. Okay, so we can represent this equilibrium constant Kc in terms of pressure as well, that is in terms of partial pressure. This is not very difficult term. This is a very simple thing. Okay, so if we if we want to uh, if we want to change the form of Kc in terms of partial pressure, then we use the ideal gas equation. Okay, so the ideal gas equation is, what is the ideal gas equation? You must know it properly. Pv is equal to nRT, right? Or V is equal to, no, P is equal to N by V into RT, or P is equal to this N by V is the concentration, right? RT. Let's consider this to be question number 1. This N by V, number of moles per unit volume, is the molar concentration. Okay, so we simply represented it like this. Now we know, now we already know a value that we have derived earlier, that is Kc is equal to what? Kc is equal to, we can write concentration of the products, that is C D D by A and B. So we can see over here, in terms of this concentration, we can write P by RT, right? In terms of this concentration, we can write P by RT. So it can be written as Kc is equal to concentration. So P P capital C, small c. So capital C will be written as subscript and small c will be written as superscript. Okay. Similarly, P D D, P A P B B. Now we have replaced this concentration by P, but RT will be there, right? Into RT 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 RT. There will be 4 RT, right? RT, 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 RT. So look at here. RT is a constant, okay? That will be for, like, even for C, D, A, and B, that will always be constant. So we will only write the power of that, okay? So in RT, look at here, the product side, C and D, right? Now, if this RT comes here, that will be in the denominator. So in the denominator side, we will write small c and small d, and in the numerator side we will write small a and small b. I hope you understood it properly. Okay, now this Kc is equal to, this whole thing can be represented as Kp. Okay, this whole thing can be represented as Kp into, this can be written as Rb to the power a plus b minus c minus d. Okay, wait a minute. Okay, so if we take this RT to other side, we will get Kp is equal to Kc into RT to the power c plus d minus a minus b. This is just law of indices. Okay, or Kp is equal to Kc into RT to the power, uh, this can be written as del n. Here del n is equal to C plus D minus A minus P. But most importantly, Kp is equal to PAA into P, PCC to PDD by PAA into PBB. This is the important thing that we require. Okay, so this is the equilibrium constant in terms of partial pressure. This is the this equation. This equation is for the equilibrium constant in terms of the partial pressure. In terms of the partial pressure. So I hope you understood this much. Now, for your examination as well, no matter where you are from, what you are studying, if you have chemical equilibrium topic in your chapter, then this formula is VVI for your board examination. They will ask you to relate Kp and Kc. So you can relate it like this, okay? And this is the expression for the equilibrium constant in terms of partial pressure or in terms of pressure, okay? So I hope you understood this derivation. I have included both the form this and this in a single derivation. So you can just do it like this. Now, what is the relation of Kp and Kc? So I should have done this over here, but I have already done in the previous slide. So I'll just write the expression. Okay, Kp is equal to Kc into RT to the power del n. This is the relation of Kp and Kc, where this del n is equal to C plus D minus A minus B. Or we can write bracket over here and plus over here. That is the addition, the C plus D. C and D are the stoichiometric coefficient of products minus the sum of the stoichiometric coefficient of the reactants. Okay, so for derivation we can just follow this one. Okay, so this was very simple thing. I hope you understood properly. Now there is a practice question that is given as below, so you can do this question properly. Just solve this question and write the answer in the comment box. Okay, I have included this question for your practice. Okay, so do the question, write the write the equilibrium constant expression for this reaction, that is sulfur dioxide plus oxygen giving sulfur trioxide. This won't be very difficult for you guys. Just write the answer in the comment section. Okay, that's all in this video. I hope you understood everything about this video. If you like the video, please share this video as much as you can, and don't forget to subscribe my channel. Bye bye.